Okay, today we are going to unlock a super simple trick that, I'm not kidding, is about to completely change the way you look at trigonometry. So let's just dive right in.
So are you tired of trying to memorize the entire unit circle? You know, cramming the sine, the cosine, the tangent for every single angle into your brain. Yeah, we've all been there. It's a pain. But what if I told you there's a much smarter way to do it? A way that actually makes sense?
Well, the secret, the whole key to this, is a brilliant little concept called the reference angle. Seriously, this is the thing that unlocks everything. It simplifies the entire unit circle down to just that first little quadrant.
So, what exactly is a reference angle? Well, simply put, it's the smallest, sharpest, acute angle that any other angle makes with the horizontal x-axis. That's it. It's always positive, and it's always going to be squished between 0 and 90 degrees.
You know, the best way to picture this is to think of it like a mirror angle. I mean, every single angle out there, I don't care how big or weird it is, has a perfect mirror image right back there in that first quadrant. And that right there is the insight that just changes the whole game.
Okay, let's look at an example. Take 150 degrees. So that angle is over in the second quadrant, right? Well, its reference angle is just 30 degrees. See how that works? 150 degrees is just 30 degrees shy of that flat, horizontal 180-degree line. That little gap, that distance back to the x-axis, that's the reference angle.
All right, so now that we've got this powerful idea, let's turn it into a foolproof recipe. I'm going to walk you through a really simple 4-step method that works every single time.
Now here's a really crucial point. The reference angle, it gives us the number, right? The value. But it doesn't tell us if it's positive or negative. For that, we need its essential partner in crime, the CAST rule.
And this table lays it out perfectly. The CAST rule is just a super easy mnemonic to remember which trig functions are positive in each quadrant. So look here. In quadrant I, the A means all are positive. In quadrant 2, S means only sine is positive. Down in 3, T tells us just tangent is positive. And finally, in 4, C is for cosine. You've probably heard it. All students take calculus. That's all you need.
So here it is, the whole process laid out for you. It's just 4 steps. Step 1, figure out which quadrant the angle is in. Simple. Step 2, calculate that reference angle we just talked about. Step 3, find the trig value for that easy little reference angle. And finally, step 4, use the CAST rule to stick the right sign, positive or negative, on it. Okay, enough talk, let's actually see this in action.
Yeah, theory is great and all, but we need to make this real, right? So let's put this trick to work. We're going to run through a couple of examples right now.
All right, first up, here's our challenge. Let's find the cosine of 210 degrees. And yeah, no calculators allowed.
Okay, let's follow our steps. First up, where is 210 degrees? Well, it's past 180, but not yet 270, so yep, it's in quadrant 3. Next, we need that reference angle. We just find the distance from the closest x-axis, which is a 180-degree line. So 210 minus 180, that gives us 30 degrees. Easy.
Okay, we're already on to step 3. We need the cosine of our reference angle, which is 30 degrees. Now, that's one of the basic ones we should know. It's about 0.866. And now for the final piece of the puzzle, the sine. Let's use CAST. Remember, all students take. Take is for quadrant 3, which means only tangent is positive there. So our cosine value, it's got to be negative.
And there you have it. We just combined the value we found from the reference angle with the sine we got from the CAST rule. So the cosine of 210 degrees is negative 0.866. See, so much simpler than memorizing.
All right, you ready for another one? Let's tackle something that trips a lot of people up, negative angles. What are we going to do with something like the sine of negative 45 degrees?
You know, the trick with negative angles is surprisingly simple. All you have to do is make them positive. Think about it. You can always add or subtract a full 360-degree spin without actually changing where the angle points on the circle, right? This gives us what's called a coterminal angle, basically an angle that lands in the exact same spot. So let's just add 360 to our negative 45, and we get 315 degrees. Now we have a positive angle to work with.
And from this point on, it is the exact same 4-step process. So 315 degrees, where does that land? It's almost a full circle, so it's over in quadrant 4. And its distance from the closest x-axis, which is the 360 line, is just 45 degrees. Boom! Our reference angle is 45.
Okay, we know the sine of 45 degrees is about 0.707. Now for the sine. We use our CAST rule again.
All students take calculus. Calculus is for quadrant 4, so only cosine is positive there. That means our sine value has to be negative. And our final answer, the sine of negative 45 degrees is negative 0.707.
So why is this method so darn powerful? I mean, it's because it's not really just a trick. It's more like a new superpower that simplifies pretty much all of trigonometry. I mean, the power of this trick is just incredible. For starters, you only need to memorize the values for that first little quadrant from 0 to 90 degrees. That's it. It works for literally any angle, positive, negative, or even those crazy huge angles greater than 360. It also helps you find exact values without a calculator, and it pairs perfectly with the cast rule for super fast, accurate answers. You're not just memorizing less, you're actually understanding how the circle works. You're working smarter, not harder. So by combining the simple idea of the reference angle with the logic of the cast rule, you've just unlocked a universal method. You can now confidently tackle any angle that gets thrown your way. So really, the only question left is, are you ready to solve any angle?